Hello, everyone. My name is Nathalie Florival, and Erin, Bolivar, and Widya, we have the pleasure to work as a team over the past few weeks on our final project. Erin and I have chosen the decision tree for our model, and we have picked the Airbnb as a dataset. The, the dataset is one of the datasets that we have used in our previous class. It has 22 columns and approximately 3,500 rows. The very first step that we did is that we import our data. Then we feature engineer where we could categorize bed into 3 categories. The first category is few, where we have any house between 0 and 3, we categorize as few. And any beds between 4 and 7, we categorize as many. And any house that has 8 to 16 bedrooms, we categorize as very many. And we also use room type, property type, neighborhood cleans, bed type, accommodate, and price category. This is the display of our data frame. Now I will turn it over to Erin, who will have the pleasure to present you the rest of the model.
Thank you, Natalie. And so we have determined that when doing a multi-classification model, which is what we're using the Airbnb price category for, it's very important to establish a baseline accuracy to determine how useful is this model, and if it was compared to if we were to guess one particular price category for all of the fields, how accurate would it be? So we've set this up and created a data baseline data frame using the SQL syntax, and we have selected each distinct price category, the count of listings, and the percentage of each one of those categories. And so that's displayed here now. You can see that the price for category of $75 to $150 is the most popular, just over 1,100 listings with that price point, and that represents 33% of the values in our database. So from there, we can establish the baseline is 33%. If we guessed each value as being between the $75 and $150 price category, we would be right 35%, or excuse me, 33% of the time. So now that we've established our baseline, we split the data into training and test using a 70-30 split. We imported the correct packages to run our decision tree multi-classification model, and that's decision tree classifier, vector assembler, string indexer, and the pipeline. In the data here, we are using the indexer function, and what this does is it allows strings to hold numerical values so that it can be used in our model. We've done this for each one of our variables. We've created a data frame for the assembler, and we've combined all of our independent variables within this assembler data frame with an output column titled features. From there, we're going to use the decision tree classifier dependent variable, which is price category index, and that's going to be housed in a data frame titled DT model. We use the pipeline function for the imputation, and then from there, we fit the model on the training data, and then we fit transform on the actual test data. So once that is complete, we're showing the predictions as compared to the actuals. What this is showing is just what the price category index was and then what the prediction was. This is just for the first 20 rows of the data, so it's not the full robust data. And from here, we import the multi-classification evaluator. This will determine how accurate our model is. We've created a data frame to house the predictions and the price category, and those are housed in the accuracy data frame. So from here, we're going to print the actual accuracy of our decision classifier, and we were able to achieve accuracy of 55% compared to baseline of 33%. That is significantly higher than baseline. We've had experience running this models in different environments, and we were never actually able to get above 56%. So in conclusion, we view this as a useful model. It's well above baseline, and it is showing an accuracy of 55%. From here, I'm going to turn it over to Bolivar, and he will talk about logistic regression.
Thank you, Aaron. As you mentioned, so we also run a logistic regression model, and we also use the Airbnb dataset that Nathalie described. In our case, we chose all the variables, and then we did a clean in the data. At the end, we ended up with 16 columns and 24 rows. As part of the logistic regression, the pre-cleaning data, so we select the variables that were considered for that didn't have a lot of gaps in terms of missing values. As well, when we encountered the category of variables, we did some transformation from categorical to numerical. So that way, when we had to run the logistic regression model, we were able to do that. So that's part of the model. Also, we use a similar method as the classification model that we use 70-30%, 70% for training data and 30% to test our model. All right, and from here I will pass it to Widya that will continue with the model.
Thank you, Bolivar. And after we transform our categorical variables, we then run a logistic regression regression, and then here our dependent variable is the price GTE 150. It's basically whether or not the price of the property is renting for more than $150 or not per night. So 1 is more than $150 and 0 is less than $150. So after we run the logistic regression model, we define the pipeline to pass the data through the indexer, encoder, and assembler stages that we did earlier to transform the categorical columns. And then we fit the model into the training data. And then after that, we transform the model into the test data. So here are the first 20 rows of comparison between our the actual values of our dependent variable and the prediction of our model. You can see here the actual value is 1, our prediction is 0, and here the actual value is 1, the prediction is 1, and the actual value is 0, the prediction is 1. So the final step is for us to evaluate our models. We chose 4 different evaluation metrics. The first one is area under the curve. Our area under the curve is 0.8679, which indicates that our model has good discriminatory power in distinguishing between the two classes, the less or more than $150 per night. And the second evaluation matrix is the accuracy, and our model correctly classified 78% of the instances. And then the third one is the confusion matrix. In this case, our model classified 437 true positives, 456 true negatives, but misclassified 79 false positives and 57 false negatives. The last evaluation matrix is the area under PR curve, which in our model, the number is 0.8327, and it indicates that the model has a good precision and recall performance. That is all for our presentations. Thank you so much for listening, and